All right, number 14 here. Even, odd, or neither. Remember, the test we do is we test to see if the opposite of x makes any change and what that change is. Well, basically, if I put the opposite of x in there, that is going to create negative 3x cubed, like we've discussed. That is going to change this here, so it's going to be minus 2x, but it's going to have no effect on the back end, minus 4. So this is not the same. This is definitely not the opposite, so we would say that this is neither even or odd. All right, now this one here, if I do the change, if I put in the opposite of x, I'm going to get opposite of x cubed, so we will get a change, and minus 8x, change again. So that's exact same as distributing a negative 1 to each part. So that is the opposite, and we get odd. And it's this one here, kind of hard to see on this, but here's the y-axis right here. Every point is a mirror image of the other point, so this is definitely y-axis symmetry, so this would be an even function graphically. All right, looking here. We want to put this into the calculator. I want to show you what happens here when we look at this. So what do we got? We got 4x minus 2 cubed minus 3. So let me open up a new document here. So we got a new document. Let's get a graph in there. And then we said 4, and then I believe it was x minus 2, correct? You guys can't tell me because this is a video. Raised to the third power. Make sure you get outside of that, and then you do minus 3. All right, so if you type it in, check it always before you hit enter, and then hit enter. Oh, there I am there. I wanna zoom in a little bit, see what that looks like. So menu, let's do this. Let's analyze, nope, sorry, Windows zoom. Let me just zoom in, put the center like right there. Put the center like right here, 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 here. And what we can see here is what's happening, and it just zoomed in a bunch to kind of get the idea here. But let's just kind of see what happens here. So basically what we have on this one is we are going to analyze the graph now, like I discussed. Analyze graph, and let's look and see what the minimum is. So if I go like, you know, from here all the way over to here, they're going to tell me there's a minimum value. It's right there. So what that tells me as I'm cruising through this one here is that as I go through, it's not really going up and then peaking down. It's just kind of like the cubic function going like so. And here's another thing we can do. Hold on, Control Escape here. Now, I know this can be a little, excuse me, a little tricky for you. Excuse me, a little tricky here for you. But if we analyze the graph and look for a maximum, like where's the maximum from here and then all the way to here? As you see this, just kind of watch this here. It's showing you as I progress within the interval that's shaded there where the maximum point is. So if you look at that all the way up, the maximum point goes everywhere here. So it's not hitting a peak and then dipping down and then going back up. It's staying the maximum. So this is increasing from left to right the whole entire way. Okay, so back to this one now. Like, how would you draw a sketch for a problem like this? Because it's just going to kind of go like this. That's not a great sketch, but it's just going to go like that. So where is the function increasing? It's actually more simplistic idea. It's increasing from negative infinity to infinity. Where is the function decreasing? It's not. If it's always increasing from left to right, it can't be decreasing. It can't be constant. Okay, and what is the local max? These are all going to be kind of not available for this type of a problem. What is the local maximum value? Don't have it. And then what is the local minimum? You know, not available. So basically, we're not peaking at any point. It's just kind of going through like that. Now, if you think that's not a good one, I don't know, maybe I could have picked a different problem for that one. But basically, I just want you to know, if you really show me that, you really know what's going on for this problem. Now, I would highly suggest you go back to, you know, what was this? This was 2.3. I have made a video already on 2.3, and it's still on our Google Classroom, so you can go ahead and look up this exact problem on 2.3 if you want to see some extra practice with that.